All right, so let's dive into Docker.
Okay.
You sent a ton of material about it.
Yeah.
So clearly you're serious about getting a handle on this thing,
Right.
how it's changing cloud computing.
Yeah, it's definitely more than just like a buzzword these days.
Okay.
Docker is really all about making, building, and running applications in the cloud simpler, faster, more efficient.
Yeah.
And all thanks to this really clever idea called containerization.
Okay, containerization. So that's where we need to start.
Right.
I get that it's about, packaging up apps,
Yeah.
but how does that actually work?
Imagine this. You've built this really amazing app,
Okay.
but getting it to run smoothly on different servers or like in the cloud
Right.
can be a real headache.
Yeah.
Different environments, different setups. It's a mess.
Yeah.
Containers solve that by bundling your app
Okay.
with everything it needs to run.
Uh-huh.
Libraries, dependencies, the whole shebang,
Yeah.
all neatly packaged together.
So it's like shipping a self-contained
Exactly.
any environment
Right.
for my app.
Exactly. These containers are like little virtual machines,
Okay.
but much lighter and faster
Okay.
because they share the host operating system's kernel.
Mm-hmm.
This means they're super portable.
Right.
You can build it once, run it anywhere that supports Docker.
So no more like compatibility nightmares.
Exactly.
That's a huge win
Yeah.
for developers, right?
It's huge.
But why is Docker the name everyone's talking about?
Right.
Are there other tools for this containerization thing?
There are, like, LXC has been around longer,
Okay.
but Docker really nailed the user-friendliness.
Okay.
It's intuitive, it's well-documented, and it has this massive ecosystem of tools and resources.
Ecosystem. So it's more than just the software itself.
Way more.
Okay.
Think Docker Hub, a giant library of pre-built images.
Yeah.
Remember those container blueprints we were just talking about?
Right.
So you need a specific version of Python or a database for your app.
Yeah.
Chances are there's an image ready to go on Docker Hub.
Okay.
It's a huge time saver.
It's ready to go.
Ready to go.
That's pretty cool.
Yeah.
So Docker's got this huge community,
Massive.
all these ready-made components. What else makes it stand out?
Image management is a big one.
Okay.
Docker's approach is incredibly efficient.
All right.
Images are built in layers.
Okay.
So if you make a small change, you don't have to rebuild the entire thing.
Okay.
Just the changed layer, which saves time and storage space.
Right.
Right.
So, okay, I'm starting to see why it's so popular.
Yeah.
But all this talk about images, containers, ecosystems.
Yeah.
Can we zoom in on the actual nuts and bolts
Of course.
of how Docker actually works? Like, what are the
Yeah.
key parts
Yeah.
that make it all tick?
Absolutely.
How-
So at the heart of Docker, you've got this client-server architecture.
Okay.
You've got the Docker daemon or Docker. It's a background service running on your host machine.
Yeah.
It's like the brain of the operation,
Yeah.
managing everything that Docker does.
So the daemon is the one calling the shots.
Exactly.
What about me, the developer?
Right.
How do I interact with that?
That's where the Docker client comes in.
Okay.
It's a command line interface you use
All right.
to send commands to that daemon.
Mm-hmm.
Things like building an image,
Yeah.
running a container,
Uh-huh.
or pulling an image from Docker Hub.
Right.
They communicate through the Docker API.
Okay.
It's like a language they both
The
understand.
client talks to daemon.
Yeah,
Daemon makes things happen.
exactly.
Got it.
Yep.
What kind of commands are we talking about?
You'll be using commands like Docker build
Okay.
to create images from those Docker file blueprints,
Right.
Docker pull to download images from registries like Docker Hub,
Yeah.
Docker Run, to actually start up a container
Right.
from an image. And Docker push to share your custom images with the world.
Share them out.
Yep.
All right. Starting to get a feel for the workflow here.
Right.
But let's talk more about those images and containers.
Yeah.
They seem to be like the heart of this whole Docker thing.
the heart of it.
What exactly are they?
So think of an image as a snapshot,
Yeah,
like
okay.
a frozen state
Right.
of your application and all its dependencies.
Mm.
It's like a template
Okay.
for creating containers, which are the live running instances of your app.
Okay.
So,
Got it.
yeah, welcome back.
Back for more Docker.
All right, so
Yeah.
last time we left off talking about those images and containers,
Right.
the dynamic duo.
Yeah, the heart of it.
You ready to dig a little deeper?
Yeah, I'm starting to grasp the basic idea,
Okay.
but I'm really eager to understand how these pieces actually fit together.
Yeah.
Like in practice.
Let's start with those Docker files. Remember those blueprints we mentioned?
Yeah.
So it's basically a set of instructions that you write
Okay.
to tell Docker exactly how to build your image.
Okay, so it's like a recipe for my containerized app.
Exactly.
What kind of instructions would I find in there?
Think of it as a step-by-step guide.
Okay.
You start by specifying a base image, like a starting template, often from Docker Hub.
Okay.
This could be an operating system like Ubuntu,
Right.
a specific programming language environment,
Okay.
or even a pre-configured application server.
So it's like choosing the foundation for my app to run on.
Exactly.
Okay.
Then you add instructions
Yeah.
to copy your application code into the image.
Right.
Install any necessary libraries or dependencies,
Okay.
set up environment variables, expose ports for communication,
Right.
and define what command should run when the container starts up.
So it's all about laying down the groundwork for my app to run smoothly inside that container.
Exactly. And the beauty of Docker files is that they're just simple text files, easy to read, easy to understand,
Right.
and version control, just like your code.
That makes collaboration a lot easier.
Exactly.
But wait, you mentioned that images are immutable,
Right.
meaning they can't be changed once they're created.
Right.
So how do I update my app if I can't change the image?
That's where the layered structure of Docker images comes in.
Right.
When you make changes to your app or its dependencies,
Yeah.
you create a new Docker file with the updated instructions.
Okay.
Docker then builds a new image, but instead of rebuilding everything from scratch, it only recreates the layers that have changed.
So it's like adding a new coat of paint to a house.
Yeah, that's a great analogy.
You don't have to rebuild the entire structure.
Exactly.
Just update the surface.
Yeah, this layered approach
Yeah.
makes Docker incredibly efficient.
Okay.
It saves storage space, makes image builds much faster.
Right.
Because only the necessary changes are processed.
That's really clever. Yeah. So I've got my image built. What happens next? How do I actually get my app running?
That's where the Docker run command comes in.
Okay.
This tells Docker to take your image, spin up a container,
Right.
a live instance of that image,
Okay.
and start running your application.
Okay.
And remember, those containers are isolated environments,
Yeah.
so they don't interfere with each other.
Right. Those little sandboxes we talked about.
Yeah.
But how do these isolated containers talk to each other?
That's a great question.
Yeah.
Or to the outside world.
Right.
That's where networking comes in.
Okay. I was going to say,
Yeah.
networking has to be part of this picture.
Yeah, Docker has really robust networking features
Okay.
that let you control how your containers communicate with each other
Right.
and with external networks.
Got it.
It's like setting up the communication channels
Yeah.
for your application.
I'm guessing it's not as simple as just plugging in an Ethernet cable.
Not quite, but Docker makes it surprisingly manageable.
Right.
There are different network drivers to choose from,
Okay.
each with its own use cases.
Yeah.
The default, bridge network, it's like a private network
Okay.
for your containers that are running on the same host,
All right.
letting them communicate by name.
So it's like setting up a mini internal network just for my Docker containers.
Exactly.
Okay.
But what if you need containers running on different machines to talk to each other?
Right. Right.
That's where overlay networks come in,
Okay.
creating a virtual network that spans multiple hosts.
Ah, so it's like building bridges between these isolated container islands.
Yes, exactly.
That sounds essential for building larger distributed applications.
Absolutely. And then you've got other options like host networking, where the container shares the host's network stack.
Okay.
Useful for performance,
Right.
but with less isolation.
Right.
And then there's none networking,
Okay.
which completely isolates a container for security reasons or specific testing scenarios.
So Docker gives you a lot of flexibility to control how your containers interact.
Lots of options.
But what about data?
Yeah.
If containers are temporary,
Right.
how do I handle data that needs to be stored persistently?
That's a great question.
Yeah.
And that brings us to the topic of storage in Docker.
Okay.
So there are several options,
Mm-hmm.
but the most common and powerful is using Docker volumes.
Volumes. Are those like external hard drives for my containers?
That's a good way to think about it.
Okay.
Volumes are dedicated storage areas
Yep.
managed by Docker that live outside the container's file system.
Right.
This means they can be shared between containers.
Okay.
They persist even if a container is deleted,
Okay.
and they can be easily backed up and restored.
So it's like having a separate storage unit
Yeah.
that I can attach to any container.
Exactly.
as needed.
You can create volumes using simple Docker commands, and then you can mount them into your containers using the Vaadin sphere mount flag with Docker run. You can also define volume configurations in your Docker Compose files.
Docker Compose.
Which we'll talk about later.
Okay, that sounds intriguing.
Yeah.
I sort of feel like there's a whole universe of Docker tools to explore here.
There is.
Yeah.
And Docker Compose is a real game changer when it comes to managing multi-container applications, which, as you mentioned earlier, are becoming the norm with microservices architectures and distributed systems. But we'll save that deep dive for next time.
Can't wait. Until then, I'll be practicing my container commands. And dreaming of those efficient image layers. All right. See you next time.
See you then.
Okay, back for round 3 of our Docker deep dive. We've covered images, containers, networking, even storage.
We have.
It's like we've built this whole miniature data center in our minds.
We've laid the groundwork. And now it's time to bring in the heavy machinery, Docker Compose. Remember how we talked about managing those multiple containers, especially for those modern apps built with microservices?
Yeah, my head was spinning a little bit trying to picture coordinating all those containers. It's not like I'm going to manually start and configure each one.
No, that's where Docker Compose comes in. Saves the day.
So instead of juggling individual containers, Docker Compose lets me define the entire application stack.
Exactly.
All those interconnected services. In a single YAML file called docker-compose.eml.
That's right.
So it's like a master control panel. For my whole app, laying out how each container should be built. Configured, connected.
You got it. So each container is represented as a service. In the file, you specify things like the image to use, any environment variables, ports to expose, volumes to mount, and even dependencies between services to make sure that they start up in the right order.
So if my app needs like a web server, a database, a message queue, I can define all those containers and their relationships in this one file.
Exactly. And then the magic happens with a single command, Docker Compose. Docker Compose takes that file, orchestrates the creation and startup of your entire application.
Hold on, orchestration. That sounds intense.
Think of it as conducting an orchestra. Docker Compose ensures each container, each instrument in your app's symphony starts up correctly, connects to the right networks, mounts the necessary volumes, and gracefully handles any dependencies.
So it's not just about starting containers. It's about managing their entire life cycle.
Exactly.
And ensuring they work together harmoniously.
Precisely. And here's the best part. Docker Compose makes your application portable across different environments. So whether you're developing on your local machine, testing in a staging environment, or deploying to production, the same docker-compose.eml file can be used to bring up your entire application stack.
No more configuration headaches when moving between environments. That's huge. But let's be realistic. Docker Compose might be great for like local development or smaller deployments. But what happens when you need to scale an application to hundreds, even thousands of containers across a cluster of servers? That's where those heavy-duty orchestration tools come in, right?
You're exactly right. For massive deployments, complex microservices architectures, you need the power of tools like Kubernetes. So they manage the deployment, the scaling, networking, and health of containerized applications across an entire cluster of machines.
So there's like Docker Compose on steroids.
That's a great way to put it.
Capable of conducting an entire symphony of containers across this vast digital landscape.
And while Kubernetes is a whole other world to explore, it's important to remember that Docker is the foundation that it's built upon. So those images, those containers, the core concepts we've discussed, those are the building blocks of modern orchestration, cloud-native development.
Wow, this whole journey's really opened my eyes.
Glad to hear it.
To the power and potential of Docker.
It's
not just about containers. It's about transforming how we build, deploy, manage applications in the cloud.
It's been a pleasure diving deep with you.
Likewise.
You're well on your way to mastering this transformative technology.
And to you, dear listener, thanks for joining us.
Yes.
On this Docker Deep Dive.
Absolutely.
Remember, the world of containers is all about efficiency, portability, and scalability. And with Docker, you've got the tools to unlock that power.
You do.
Happy Dockering.
Happy Docker.
Until next time on the Deep Dive.